Hi everyone. Reading for comprehension is such a critical skill in life and is certainly true in the field of mathematics. I will read example M.1 and your job is to make sense of it all. A student needed to solve x plus 4 equals 3x plus 6 to determine the x value or x values of the solution of a linear system. Review the student work below and take notes on equation equivalency. Okay, for those who are scratching at your heads at some or perhaps all of what I just read, allow me to explain. As a student, I want you to learn how to analyze mathematical language like you would diagram a sentence written in English. In the first sentence, we are told two things: what the student needs to do, followed by why the student needs to do it. These are two critically important questions that all students will need to ask themselves throughout this semester. Allow me to underline what the student needs to do. A student needed to solve x plus 4 equals 3x plus 6. This is the diagramming part of our work here. And I will also draw a box specifically around what needs to be done, and that is solve the statement x plus 4 equals 3x plus 6, whatever that means. We are also told why the student is doing this. That is to determine the x value or x values of the solution of a linear system. And I will underline this part of the sentence in a different color. So now for a quick study tip break. Study tip. This study tip is about color coding. So there's research that says color coding your notes can help with revising and reviewing important information both now and at a later date. Now, I may not always use color coding in my notes, but if it's something that works for you, then please do so as needed. Now let's get back to the math. The part of the sentence that we were just looking at that's underlined there in that pink color tells us about the motivation behind the algebraic computation. Right now, this part of the example is expected to still produce a thought bubble above your head with a question mark inside. And that's perfectly okay. We will talk about linear systems in a later section. Let's not focus on the motivation. Let's focus on what we're being asked to do. And that is to review the student work below and take notes on equation equivalency. So you take notes, I will start explaining. The first thing I want you to notice is that the student's work begins with the equation that was given from the first sentence. There's the equation right there. And I know that it's an equation because of two things. There's an equal sign, and there's an expression on each side of the equal sign. So an equal sign with two expressions. The student needs to solve this equation, which means they need to determine all values of the variable that result in a true statement. Now, that's a really important thing for us to understand about solving, because this means that we get to make an initial assumption that the starting equation is in fact true. That is a critical first step when analyzing this work. So for this equation, we make an initial assumption that our given equation is in fact true. There's no way around that. We have to make that assumption at the beginning. So now we're going to check each subsequent equation to see if it's equivalent. The next statement I can see is another equation. Thus, we are going to use the rules of equality. Rules of equality apply specifically to equations. One of the rules of equality allows us to add or subtract the same quantity from each side of an equation. You can think of this as a balancing act with the given equation. So we can subtract an x from both sides of this equation. Now, each side gets simplified by combining like terms. The x minus x will cancel out on the left side, and 3x minus x will result in 2x on the right side. And bingo, the second equation is equivalent to the first. This is great. Let's continue checking. Let's subtract 6 from each side of the second equation and simplify. Four minus 6 on the left side will result in -2. And 6 minus 6 on the right side cancels out. This is good. Yet another equivalent equation. Let's continue. Another rule of equality allows us to multiply or divide both sides of an equation by the same value, with one exception, and that is we cannot divide by 0. But we can divide both sides of the third equation by 2. On the left side, -2 divided by 2 simplifies to -1. And on the right side, 2x divided by 2 simplifies to x. Again, we have another equivalent equation. And this student has successfully solved for x. Now, the fifth equation is essentially the same as the fourth equation, with just the left side and the right side swapped. Another rule of equality lets us swap the two sides of an equation completely for free. So this student did successfully solve. If you're into boxing in the answer, you might box in that final answer down there. And this shows us how we make an initial assumption that the given equation is true, and then we check to see if each subsequent equation is also true by using the appropriate rules of equality. And this concludes our review for example M.1.